Welcome to question 5 of the 2006 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 5 we have let x be a normally distributed random variable with a mean of 72 and a standard deviation of 8. Z is going to be the standard normal variable. Use the result that the probability that z is less than 1 equals 0.84 correct to 2 decimal places to find the following. So for part A we want to find the probability that x is greater than 80. So out to the side we're just going to draw a couple of normal distributions. This first bell curve is going to be x, which is normally distributed with a mean of 72 and a variance of 8 squared. So for this distribution we know that this value here is going to be 72 and we're asked for the probability that x is greater than 80, which is going to be this value here. And because our standard deviation is 8, that is one standard deviation above the mean. Now underneath that distribution we're going to do the standard normal, which has the same shape, and it is distributed normally with a mean of 0 and a variance of 1 squared. And we know that this value here, the mean, is 0, and previously we were given that the probability that it's less than 1, so this area that's being shaded at the moment, was equal to 0.84. So that was this piece of information that was given to us in the question. So because these two distributions are the same, they're just variations of each other. So because they're both normally distributed, this area up here also corresponds to the probability that x is greater than 80. And that value there is equal to 0.16. So therefore, we know the probability that x is greater than 80 is equal to 1 minus 0.84, which is equal to the 0.16 that we found before. So that is the answer to part A. So from the examiner's report, we can see that some students did not clearly understand the relationship between the random variables z, which was the standard normal, and x, which was the other normal distribution we were given. So the things you need to be aware of is that they are symmetric bell curves and that the areas within them should correspond. For part B, we're going to use all the same information as before, but now we're looking for the probability that x is between 64 and 72. So once again, if we draw out a quick diagram of our bell curve, this is going to be x, which is distributed normally with 72 as its mean and 8 squared as its variance. This mean value here is 72, and this time we're looking at 64. And we want the probability that it is between 64 and 72, which is this area here. And remembering that we can relate this to that standard normal distribution. So this distribution will be z, which is distributed normally with a mean of 0 and a variance of 1 squared. And we know that this value here, the mean, is 0, and the probability that it is less than 1, so this area here, as we highlighted before, was 0.84. So that's this information. And that made this tail here 0.16. So if that tail is 0.16, then this tail here is also 0.16. And we have one more property of this curve, which is that the probability that it is less than the mean is 0.5, and that also applies to the distribution up here. So that total probability should be 0.5 when it's less than 72. So with all of that in mind, we find the probability that x is between 64 and 72 is going to equal 0.5. So the probability that it is less than the mean, subtract away that tail of 0.16, which gives 0.34 as the answer to this question. So approximately 45% of students got that correct, and there was a few common incorrect responses of 0.32 and 0.68. And next for part C, we want to find the probability that x is less than 64 given that x is less than 72. So that is we're after the probability that x is less than 64 given that x is less than 72. And using our knowledge of conditional probability, we know that that is going to equal the probability of the intersection between the two, which is going to be when x is less than 64, divided by the condition, which is the probability that x is less than 72. And once again, if we quickly look at our bell curve, where this is the random variable x, which is normally distributed with a mean of 72 and a variance of 8 squared, we know that the mean of this is 72, and before we discussed that the probability that you are less than the mean is 0.5, that is that 50% of the chance lies below the mean. And we've also seen in the previous questions that 16%, or 0.16 as a probability, lies below one standard deviation below the mean. So that is the probability that x is less than 64. So using that information, we find that the top line, the probability that x is less than 64, is equal to 0.16 divided by the probability that x is less than 72, which is 0.50, and of course that can be simplified to 16 over 50, which is then in its simplest form as the fraction 8 over 25. So that is the answer to part C. Part C was more challenging than the previous two questions, with only 27% of students receiving full marks. Many students realised the conditional probability was required, but were not able to apply it correctly. So that is, they couldn't set up the necessary fraction to calculate it. Notation was poor and often made it difficult to ascertain if the student really understood what was required for this question. The denominator was usually correct, but the answer to part B was often placed in the numerator. So students thought that part B related to this where it didn't. Some students did not further evaluate 0.16 over 0.50 correctly, and you're reminded not to leave decimals as part of fractions, and always to simplify as much as possible with those numeric answers.